lesson 9.2, we have more properties for circles. Now, in the diagram we have to the right here, the top right, segment AB with endpoints on the circle, all right, the endpoints are on the circle, is called a chord. All right, now segment CD is both a chord and a diameter. All right, because it passes through the center of the circle. All right, now here we have the chords and arc theorem. If two chords in a circle are congruent, then their corresponding arcs are congruent and vice versa. Okay, so here I have these two chords. Since they're congruent, their corresponding arcs are also congruent and vice versa. If the arcs are congruent, then the corresponding chords are congruent. All right, let's do some examples applying these ideas. Example 1, find the indicated measure. All right, here I have a chord of 8 units. Here I have another chord of 8 units. So these two arcs have to be the same. All right, so those two chords are the same. These two arcs are the same. So arc AC is 132 degrees. All right, now for part B, here I have two arcs that are congruent. So their corresponding chords are also congruent. That's 9. So QR is 9. For C, I have these two chords that are congruent, and their corresponding arcs are congruent. So that's 81 degrees. All right, then if we go all the way around the circle here, that's what I'm looking for. All right, how am I going to figure that out? Well, I just take these two arc measures and subtract them from 360. I'm going to write out the whole thing here, 81 plus 81, plus the measurement of arc, LOJ, is equal to 360. All right, so I have 162 plus measurement of arc, LOJ, is equal to 360. Subtract 162, and I get 198 degrees. Done. All right, for the next idea, chords and perpendicular bisector theorem. All right, if one chord is a perpendicular bisector of another chord, then the first chord is a diameter and vice versa. All right, so if DF is perpendicular to EG, if it's perpendicular to EG, and EH is congruent to HG, oh, this should be H here. Okay, then DF is a diameter. Okay, then this is the diameter. All right, if it's perpendicular and it bisects, essentially, it cuts it in half. All right, it goes the other way as well. If this is a diameter, then you know right away, oh, and it's perpendicular, then right away you know that it bisects the chord. So these two pieces are the same. And if these two pieces are the same, these two arcs are also the same. Watch out for that. All right, so example 2 says find the indicated measure. We want to find EC. All right, so I have this chord here. I know it's a diameter because it passes through the center of the circle, and it's perpendicular, so it must bisect this chord. So that piece is the same as that piece. EC is 5. All right, for part B, I have, let's see here, this is definitely a diameter, and it's perpendicular, so these two parts are the same. All right, chord is bisected, which means these arcs that go along with those bisected portions, all right, are also the same, so that's 67 degrees. Now if I want to find WXY, it's this whole piece here, so I do 67 plus 67, which is 134 degrees. For part C, let's see what I have here. All right, I have a diameter once again, This is perpendicular, so I know these two parts are the same. That's 4 as well. They want me to find xv. All right, xv. Oh, well, check this out. Here I know that this is a radius, so this must be a radius as well. All right, and since it's the radius as well, that's 5. Okay, and all right, drawing on knowledge from chapter 7, what type of triangle do I have here? That's a 3, 4, 5 triangle. All right, if you didn't recognize the Pythagorean triple, you could have used the Pythagorean theorem and figured out xv. So that's 3. All right, that's all there is to it. Next idea, the distance from a point to a line is the length of the perpendicular. All right, that's an R here. Perpendicular segment from the point to the line. All right, so this is not how you measure the distance from a point to a line. Here I have a point, here I have a line. This is not how you measure the distance. This is how you measure the distance from a point to a line. It has to be perpendicular. All right, so the distance is 4 units. All right, going to the next idea, chords and distance theorem. Two chords are congruent if they are equidistant from the center of a circle and vice versa. All right, equidistant means the same distance. All right, so two chords, we have these two chords here, and they are congruent if they are equidistant from the center of the circle. So if these two little segments here are congruent, then that means the chords are congruent. All right, and if the chords are congruent, then they are the same distance from the center of the circle. All right, let's do some examples. Example 3, find the indicated measure. Okay, well, I have two chords here. They are both 6 units away from the center of the circle, so the two chords are identical. They both measure 22 units. All right, for part B, here I have a chord that's 15 units long, another chord that's 15 units long. All right, so they must be the same distance from the center of the circle. VI and VH are the same length. For part C, I have two chords that are equidistant from the center of the circle, so the chords are the same length. All right, so if the chords are the same length, then we know that their corresponding arcs are the same measure. So that's 101 degrees. This is 101 degrees. All right, last set of problems. Find the value of the variable. All right, here I have two chords with the same length. So their corresponding arcs must have the same measure. So I have 9x minus 35 is equal to 2x plus 7. Subtract 2x. I have 7x minus 35 equals 7. Add 35. 7x is equal to 42. Divide by 7, and x is equal to 6. Done. All right, next idea. All right, here I have a diameter. It's perpendicular to the chord, so that means it bisects the chord, cuts it in half. Now, if these two pieces are the same, then these arcs are also the same. So 9x is equal to 80 minus x. Add x on both sides. I have 10x is equal to 80. Divide by 10. And x is equal to 8. Done. All right, next problem. here I have these two chords are the same length, so they must be equidistant from the center of the circle. So 2x is equal to 5x minus 9. Subtract 5x. Have negative 3x is equal to negative 9. Divide by negative 3. So x is equal to 3. That's all there is to it. Just have to be careful analyzing the circles and determining what properties to apply. If you have any questions, please make sure to ask. Begin the assignment.